The next problem is the plates of a parallel plate capacitor have an area of 100 centimeters square. So they have given the area that is 100 centimeters square. So we can write centimeter square value is 10 to the power of minus 4 meters square. Because centimeter means 10 power minus 2, centimeter square means 10 power minus 2 whole square. So 10 power minus 4 into meter square. So each plate are separated by 3 millimeter. So the plates of the capacitor is separated by 3 millimeter. Milli means 10 power minus 3 meter. Okay. So the capacitor is charged by connecting it to a 400 volt supply. They have given, so the potential that is applied to the capacitor, that is 400 volt. Okay. So then first question is calculate the energy stored in the capacitor. So initially they have not given is there any medium between the two plates. That means in between the two plates there is an air. So we have to calculate the energy stored in the air capacitor. Okay. So and second question is, if a dielectric of dielectric constant 2.5 is introduced. This is the first question. And the second question is, so if the dielectric constant, they have given dielectric constant as 2.5. If this is introduced, so between the plates of the capacitor, then find the energy stored. So now what is the energy stored if the medium is filled between the two plates of the capacitor? And also they have asked to calculate the change in energy. In between these two energy, what is the change? Okay, so that we have to find out. So we know the expression for, in order to find out the energy stored in terms of the potential and capacitance is nothing but half CV square. Here, so we are calculating the energy stored in the air capacitor, parallel plate air capacitor. Therefore, it can be written as C naught V square. Okay. We need to find out C naught. C naught means capacitance of the capacitor when the air is filled between the two plates. So C naught is equal to, we can write A epsilon naught divided by D. Okay. A is given 100 into 10 power minus 4. 100 means 10 power plus 2, 10 power minus 4. 10 power plus 2, 10 power minus 4 will give you 10 power minus 2 meter square. Okay. So we can write here 10 power minus 2 into epsilon naught means permittivity of free space. So epsilon naught value is 8.854 into 10 to the power of minus 12 farad per meter divided by distance of separation is 3 millimeter, that is 3 into 10 to the power of minus 3. Okay. So this minus 3 gets cancelled. The remaining is, or keep minus 12 as it is. This minus 3, minus 2 gets cancelled. Remaining is in the denominator 10 power minus 1. 10 power minus 1 means, so 1 by 10. So 3 by 10, 3 into 1 by 10 means 0.3. So we can write C naught is equal to, so in the numerator 8.854 into 10 to the power of minus 12 divided by 0.3. Okay. If you simplify this value, you will get 29.5 into 10 to the power of 8.854 divided by 0.3 will give you 29.5 into 10 to the power of minus 12 farad. Okay. So then we need to calculate the energy stored. So energy stored is equal to U naught is equal to half into C naught is 29.5 into 10 to the power of minus 12 into V square means V value is 400, that is 400 whole square. If you simplify this value, you will get U naught value as, or simply we can also write this as 29.5 into 1 is 29.5 into 10 to the power of minus 12 into 400 whole square can be written as 16 into 10 to the power of 4. That divided by 2. 2 ones are 2 8s are 10 power plus 4, 10 power minus 4, remaining is minus 8. Okay, so I will write here. So U naught will become equal to, after simplifying, 29.5 into 8. So you will get the value as 236 into 10 to the power of value is minus 8. 10 power minus 8 joule. This is U now. In the same way, we have to calculate the energy stored if the medium is filled between the two capacitors. Suppose if we consider the two plates of the capacitor, so if air is filled between those two plates, then if you know the capacitance, suppose if we place the dielectric medium in between the same two plates, then capacitance of those capacitors can be written as C is equal to C naught into K. That I have told you in the previous class, right? So theory class. So now calculate C value. So we can write C naught means it is nothing but 29.5 into 10 to the power of minus 12 into K is 2.5. After simplifying this, we get the value of C as 73.75. 73.75 into 10 to the power of minus 12 farad. Okay. So again calculate the energy stored. Now the energy stored will become U is equal to half CV square. So we can write half into C means 73.75 into, so V means 400 whole square. Okay. So U can be written as 73.75 into 1 is 73.75 into 400 whole square means 16 into 10 to the power of 4. Means 4 square is 16. So this 100 square is 10,000. That can be written as 10 to the power of 4 divided by 2. 2 ones are 2 eights. Okay. This 73.75 into 10 to the power of minus 12. I have forgotten to write. 10 power minus 12. So plus 4 minus 12 gets cancelled. Remaining is minus 8. So you will get the value of the energy stored as 590 into 10 to the power of minus 8 joule. They have also asked to calculate the change in the energy stored. Therefore, delta U is equal to U minus U naught, that is 590. We can take this 590 into 10 power minus 8 minus 236 into 10 power minus 8. So, by taking 10 power minus 8 as common, we can write 590 minus 236 into 10 to the power of minus 8. That will gives you the delta U value as 354 into 10 to the power of minus 8 joule. This is the change in the energy stored. The next problem is 3 capacitors, each of capacitance 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. What is the total capacitance of the combination? And determine the charge on each capacitor if the combination is connected to a source of 100 volt. See, they have given the individual capacitance, that is C1 is equal to 2 picofarad and C2 is equal to 3 picofarad and C3 is equal to 4 picofarad. These are connected in parallel. See, the 3 capacitors are connected in parallel. Parallel means their common ends are connected. Okay. So, and this combination is connected to a 100 volt supply. 100 volt supply. Okay. This is C1, C2, C3. And we know one thing. In parallel combination, potential is same, right? In parallel combination, potential difference is same, that is 100 volt only. Potential difference across each capacitance is same, but the charge is different. Charge across each capacitor is different. So in parallel combination, V is, that means potential difference is same, but not the charge. So they have asked to calculate the charge, individual charge and also capacitance across the combination. So here they have asked to calculate Q1 and Q2, charge across first capacitor, second capacitor and third capacitor, and potential capacitance across the combination, that is CP. So we know the formula for equivalent capacitance of parallel combination is Cp is equal to, it is the algebraic sum of the capacitance of the individual capacitors connected parallel. That is Cp is equal to C1 plus C2 plus C3. Therefore, Cp is equal to C1 means this 2. So, plus C2 means it is 3. Plus C3 means that is 4. That is equal to 3 plus 4 is 7. 7 plus 2 is 9. So, we write 9 picofarad. Okay. Or pico means 10 to the power of minus 12. So, 9 into 10 power minus 12 farad. Okay. And also they ask to calculate the charge. The relationship between charge and the capacitance is Q is equal to C. So Q1 is equal to C1 into V. Okay. Therefore, Q1 is equal to, here C1 means 2 picofarad. So 2 into 10 power minus 12 into V is 100 ohm. That is nothing but 2 into 100 is 200. So 200 so into 10 to the power of minus 12 coulomb. Okay. In the same way, Q2 is equal to C2 into V, that is nothing but C2 is 3 picofarad, that is 3 into 10 power minus 12 into potential is 100. 3 into 100 is 300. So we write 300 into 10 to the power of minus 12 coulomb. And also we can write the charge across the third capacitor Q3 is C3 into V, that is C3 is nothing but 4 picofarad. So 4 into 10 to the power of minus 12 into potential is 100. So that is 400 into 10 to the power of minus 12 coulomb. Okay. And also we have to calculate the charge across the combination. So charge across the combination is Q is equal to Cp into V. So determine the charge on each capacitor. They have not asked to calculate charge across the combination, but you can calculate it easily. Cp into V. Cp is 9 into 10 to the power of minus 12 into potential is 100. So 9 into 100 means 900 into 10 to the power of minus 12 coulomb. So this is about the 8th problem. The next problem is 3 capacitors, each of capacitance 9 microfarad are connected in series. What is the total capacitance of the combination? And also determine the potential difference across each capacitor if the combination is connected to a source of 120 volt. So let us consider they have given 3 capacitors, each of capacitance 9 microfarad. That means all the 3 capacitors are having the same capacitance, that is 9 microfarad, and are connected in series. All the 3 capacitors are connected in series and they are connected across a 120 volt supply. 120 volt supply. Let it be C1, C2, C3. So in series combination, we know charge is same, but potential difference is different. Right? Potential difference is different. That we know while discussing about the theory. Okay. So they have asked to calculate the total capacitance of the combination. Since all the 3 capacitors are having the same capacitance, actually the formula is 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Right? 1 by C3. But here C1, C2, C3 are equal. I have told you if identical capacitors are connected in series, then the effective capacitance in combination can be written as the capacitance of the individual capacitor divided by the number of identical capacitors which are connected together. So here the capacitance of each and every capacitance is 9 microfarad divided by the number of capacitors connected in series is 3. So 9 by 3, 3 3s are 9, so 3 microfarad. Micro means 10 to the power of minus 6 farad. Okay. So then we have found out the total capacitance of the combination, and also we have to find out the potential difference across each capacitor. We know potential difference is different, but charge is same. What is the charge? Now find out the charge. We know Q is equal to C into V. So total charge of the combination is equal to charge in the individual capacitor. So the total charge in the capacitor combination is equal to total capacitance in the combination into potential difference applied across the whole combination. So CS is known to us, that is 3 into 10 to the power of minus 6 into, so potential is 120. So we can write 120 into 3 is nothing but 360. Therefore Q is equal to 360 into 10 to the power of minus 6 Coulomb. Right. Therefore, since Q is equal to Cs into V, V can be written as Q by C. Therefore, potential difference across the first capacitor is V1 is equal to Q by C1. So, Q is 360 into 10 to the power of minus 6 divided by C1 is 9 microfarad. Right. So, that is 9 into 10 to the power of minus 6. Right. So, this minus 6 gets cancelled. 9 ones are 9 fours are, so that is 40, that is 40 volt. And in the same way, V2 is equal to Q by C2. So Q is nothing but 360 into 10 to the power of minus 6 divided by C2 is nothing but 9 microfarad. Micro means 10 to the power of minus 6. These two gets cancelled, that is nothing but 40 volt again. So V3 is also Q by C3, that is nothing but 360 divided by 360 into 10 power minus 6 divided by 9 into 10 to the power of minus 6. Minus 6 gets cancelled, as usual 40 volt. So this is the potential difference across the individual capacitor. Then next problem is, in a circular parallel plate capacitor, radius of each plate is 5 cm and they are separated by a distance of 2 mm. Calculate the capacitance and the energy stored when it is charged by connecting the battery of 200 volt. So they have given the radius of the plates of the capacitor as 5 cm, that is 5 into 10 power minus 2 meter. And the distance of separation between the two plates as 2 mm, that is 2 into 10 power minus 3 meter. So we need to calculate the capacitance and also the energy stored, and so they have given the potential across the capacitor as 200 volt. Okay. First we need to calculate the area of each plate. Area, since they have given circular parallel plate capacitor, area of a circular plate is nothing but pi r square. So A can be written as pi means 3.14, r means it is 5 into 10 to the power of minus 2 whole square. So A can be written as 3.14 into, so 5 square means 25 into 10 power minus 2 whole square means 10 to the power of minus 4. So A can be written as 25 into 3.14 means you will get 78.75 or 78.5 into 10 to the power of minus 4 meter square. This is the area. Then we need to calculate capacitance. So C can be written as A into epsilon naught by D. Here epsilon naught value is permittivity of free space. So its value is 8.854 into 10 power minus 12 farad per meter. So 78.5 into 10 to the power of minus 4 into 8.854 into 10 to the power of minus 12 divided by distance of separation is 2 into 10 to the power of minus 3. Minus 3 gets cancelled, remaining is minus 1. C is equal to, so 78.5 into 8.854 divided by 2 will be given by 347.5 into 10 to the power of minus 30. Now shift 1 point, so you will get 34. If you shift 1 point, 34.7 into 10 to the power of minus 12 farad. Okay, this is the capacitance. They have also asked to calculate the energy stored. So energy stored is given by U is equal to half CV square. U is equal to half CV square. So U can be written as half into C is 34.7 into 10 to the power of minus 12 into V square means 200 whole square. So 200 whole square. Okay. So U can be written as 34.7 into 10 to the power of minus 12, 200 whole square means 2 square means 4 100 square means 10,000. That can be written as 10 to the power of 4. That divided by 2. 2 ones are 2 twos are. Okay. So 10 power plus 4, 10 power minus 4, remaining is minus 8. So U can be written as 34.7 into 2 can be written as 69.4 into 10 to the power of minus 8 joule. This is the energy stored and the capacitance of the parallel plate capacitor.